This is the first video in algebraic models, and it is over solving 1 and 2-step equations. So first in this video, we're going to talk about the difference between an expression and an equation. We're going to go over some equation vocabulary, steps to solve an equation, what inverse operations are, and then we will do some examples. First, our learning target. So we want to be able to recognize the difference between what an expression is and what an equation is, as well as understand that equations stay equivalent when the same operation is done to both sides. And then lastly, we're going to review the steps for solving 1 and 2-step linear equations. So here in this slide, we have an expression and we have an equation. So expressions can contain numbers, variables, and operations. So for example, 4x plus 7. It doesn't have to include all numbers, variables, and operations, but it does not have to include all three. It can include only variables and operations or only numbers and operations. And then an equation contains an equal sign. If you see here that this 3x plus 5 alone is just an expression by itself. And then the 15 alone is just an expression by itself. But when I take two expressions and I set them equal to each other, then that will create an equation. Now we talked about some of this equation vocabulary in the previous slide, but we have a variable. So a variable is just an unknown value. We don't know what it represents. For right now, it could represent anything. For example, a, b, x, and z are variables. X and y are generally the most common ones that we use in equations. Next is a constant. So a constant is any number that is by itself. For instance, it can be 200, 0, it can be a negative number, a decimal, or even a fraction. These are all considered constants. And then last we have coefficients. So this is any number in front of a variable. So for example, we have 5a. 5a itself isn't a coefficient, but just the 5 in front would be considered a coefficient. The negative 7 in front is a coefficient. And the 6.7 in front is a coefficient. So these are terms that we're going to use all throughout algebra. And so it's very important that you know what the difference between these are. Now we're going to look at the steps in solving equations. So first we want to identify what the variable is, what the variable term is. Then we want to apply inverse operations to both sides. We're going to take a look at what inverse operations are on the next slide. And then our very main goal, our objective, is to get our variable alone, all by itself. Okay, so let's take a look at what these inverse operations are on the next slide. Okay, inverse operations. So we have 4 general operations that we use for solving equations: addition, subtraction, multiplication, and division. So if you see addition in the problem, so you see something that is being added, then we are going to use subtraction as its inverse operation. If you see subtraction, then we are going to use addition to undo subtraction for its inverse operation. For multiplication, most commonly you will see something that looks like this, a number with some kind of variable next to it. So even though you can't really see it, in between these two numbers is multiplication. So for multiplication, the inverse operation is going to be division. And then lastly, for division, if something is being divided, we are going to multiply for its inverse. Now we're going to look at 6 practice problems of solving 1 and 2-step equations. So first off, we're going to identify the variable term. So we've already circled it. It's going to be x, because x is our letter, our variable. Our main job is to get that variable by itself. The only thing that's keeping it from being by itself is this -3. So we see this is being subtracted, right? So in order to get rid of subtraction, we do addition. So we are going to add 3. So for equations here, you can do whatever you want to the equation, but you have to do it to both sides of the equation. There are two sides of the equation, and we separate them by the equal sign. So sometimes it helps us to draw a line, so we know that if I added 3 to this left side, then I also need to add 3 to the right side. So what happens here is I have x, and then -3 plus 3. Well, that just equals 0. And then -5 plus 3 is going to be a -2. So really, when we do problems like this and we end up with a 0, we don't necessarily have to write the 0. Okay, you're free to just write it with nothing there. So really, this just disappears. And we have x equals -2. And this would be your answer. Okay, let's look at example 2. So first, let me identify my variable, which is x, okay? I have it marked already. And then we see addition in the problem. So since this 12 is being added, we need to do its inverse operation of addition, which is subtraction. So I'm going to draw my line first, and then I'm going to subtract 12 from the left side, and whatever I have to do to the left, I must also do to the right side. So I'm going to subtract 12. And so on the last example, we put a 0, but now we're just I like to put a line and a 0. It just says that, hey, this becomes a 0, and we don't need it anymore. So on the left side, we have x, and then on the right side, we have 12. So we have 20 minus 12, which is 8. And feel free to pause the video if I'm going too fast. Example number 3. Okay, so this one we have our variable term, which is 4x. Our job, again, is to get the x all by itself. The only thing keeping that x from being on the one side of the equal sign by itself is that 4. And this is the tricky one, because remember that even though it doesn't have a specific operation, when they're next to each other, like this, side by side, we know that that is a multiplication problem. So since they're being multiplied, to get rid of multiplication, I divide. And I divide both sides by 4. And draw my line here. So 4 on the left side, 4 divided by 4 is just 1. So I have a 1, and then I still have my x. And then on the right side, 24 divided by 4 is 6. And if I want to, this 1 is technically invisible, so I don't necessarily need it. But if it helps you to write it, it's okay to write the 1x. But generally, when you see like an answer, it'll just say x equals 6. This is example number 4. Our variable, let's look, it's not marked this time, but we do have an x here. So this is the variable that I want to get alone. And we see that the operation that occurs here is division. So to get rid of division, if you remember, we need to multiply. So I actually kind of wrote that in the way of what I need to do. So I'm gonna write it up here. So I multiply. So in this case, I multiply both sides by 5. And then let me draw my line. Okay, so what happens here when I multiply 5x 5 times x. So this actually turns out to be 5x over 5. And then like we divided before, 5 divided by 5 is 1. So I get just a 1x over here. And then 3 divided by 5 on the right is going to be 15. And I'm just going to bring that down here. And as we said before, that 1 you don't necessarily have to write for the x. So I'm just going to rewrite that as x equals 15. And that is my answer. Okay, we have example number 5 here. Our variable we see is this x right here. And we see that this problem is a little bit different because I now have 3 different terms, while in the other ones I only had 2. So first, let me draw my line. So it's very important, when these are now two-step equations. I first have to deal with addition and subtraction first, and then I can deal with my multiplication and division. So first, I want to undo any addition or subtraction. So I see addition here. So to get rid of that addition, I'm going to subtract 6 from both sides. So subtract 6 here and subtract 6 from the 14 over here. Now, plus 6 and minus 6, those will cancel out to equal 0. And then I'm just going to bring down what I have still left over. So I still have a 2x on this side of the equation. And then I have 14 minus 6, which is 8. So I got rid of my addition and subtraction. Now I need to look at my multiplication and division. So in between the 2 and the x, those are being multiplied. So to get rid of multiplication, I'm going to divide. So I'm going to divide off a 2. So I have 2 divided by 2 is just a 1x. 8 divided by 2 is 4. And that leaves me with x equals 4. Okay, this next one is going to be the last example. So I have another two-step equation. Negative 5x minus 3. So I see a subtraction right here, right? So to get rid of this subtraction, first my variable is my x right here. So to get rid of this subtraction, I'm going to add 3 to the left side and to the right side. Now the 3's will cancel out to give me 0. And I'm left with a negative 5x on this side. And then 17 plus 3 is 20. And then, so I still have my variable of x, and I want to get it by itself. The only way to get it by itself now is to get rid of that 5. And so I know in between that 5 and the x, it is being multiplied. So to get rid of multiplication, I divide. And I need to make sure that I divide by a negative 5 because that is a negative 5 in front of the x. So I divide the left side by negative 5 and the right side by negative 5. And from now on, I'm just going to drop the 1 because I don't really have to write it. So negative 5 divided by negative 5 is just 1x. So we have an x here. And then 20 divided by negative 5 is going to be a negative 4. Okay, so this is the end of the practice problems for solving 1- and 2-step equations. On the next slide in Canvas, you have 6 practice problems to complete on your own. Click the next button to see and complete these problems.